For this lesson, we're going to be talking about geometric sequences, which we have seen before just under another name. Exponential functions are something we studied in a previous section, and we noticed that the pattern for those exponential functions was a constant multiple. In this example, our multiple is 3. Between each step, we're multiplying by 3, multiplying by 3. So we see that that is indeed an exponential function. Geometric sequences have the same type of pattern. So I've written this as a sequence, and we can see that between each of these terms, we're multiplying by 3, multiplying by 3, multiplying by 3. Those two are examples of exponential functions and geometric sequences with our common multiple, or in other words, a common ratio between the two. We're going to use this idea to try and identify if something is an arithmetic sequence, a geometric sequence, or if it is neither of those two. So I've got 3 examples right here, and we're looking for the pattern in each of these. This first sequence, we can see that between each of the two terms, we are adding 8, adding 8, adding 8. Now, our geometric sequences are looking for a constant ratio or a constant multiple, and this is not that. We're adding. From chapter 4 in section 4.6, we saw that the arithmetic sequences use a pattern of addition and subtraction. So we have an arithmetic sequence right here because it is a constant addition. In this one, it might be hard for you to see the multiple on this. It's going down. So let me talk a little bit about one method that I use to check what these are. So if we take 2 of the terms, if it does have a constant multiple or a constant ratio, we can find that through division. So we're going to take 24 divided by 192. 24 divided by 192 happens to simplify to 1/8. Or if you write that as a decimal, that would be 0.125. So from here to here, we can multiply by 1/8 or 0.125. From here to here, that same thing applies. We're multiplying by 1/8, and from here to here, we're multiplying again by 1/8, and you can actually see that 1/8 show up here in the fraction. So this one has a constant multiple or a constant ratio, and it is 1/8. So this is a geometric sequence. Let's take a look at this one, see if we can find the pattern now. From here to here, from 9 to 14, we're adding 5. From here to here, we're adding 6. From here to here, we're adding 7. It does have a pattern. The next one would be adding 8, but that pattern is not what we were looking for with our arithmetic or geometric sequences. So this is neither. Now, in our last example, we're going to be talking about how to see it from a graph. So I have taken the graph and I have written the y values in a sequence. For sequence notation, I find it much easier if I write the numbers down right here or in a table of values. The pattern from here to here, again, is going down. We're dividing by 2 or multiplying by 1/2. And again, if you did not see that right away, you could take those two values, 60, and divide it by 120 to get a value of 1/2 or 0.5. From 60 to 20, we're dividing by 3 or multiplying by 1/3. From 20 to 5, we're dividing by 4 or multiplying by 1/4. So this does have a pattern of multiplication, but it is not the same number each time. So this is another example of neither. This is not arithmetic, not geometric. It is neither. Thank you.